Hello everybody. So let us discuss this first chapter of the syllabus, the electric charges and fields. Okay, so first of all, what do we mean by an electric charge? Okay, so what is an electric charge basically? Charge is the property associated with matter due to which it possesses and experiences electrical and magnetic effects. A body is said to be charged if it possesses excess or deficiency of electrons. Okay, so basically when we talk about charge, we think of the electron, right? Why? Because the electron is the particle that carries charge. It is the fundamental particle that carries charge. Okay, so suppose you have a body. Let's say we have any body. Okay, say this body like this. Now this body here is made up of many atoms, and the number of positive charge present in the body is equal to the number of negative charge. I mean, the amount of positive charge is equal to the amount of negative charge. So therefore this body is a neutral body. Is a neutral body. That means electrically neutral body. But if you give electrons to this body, let's say you give electrons, okay, to this body you give electrons. So the electrons are negative charge. So the negative charge will sit on the surface of this body. Now if you count the number of negative charge present in this body, there is excess, there is more negative charge than positive charge in the body. So that means there is excess of electrons in this body. So because there is excess of electrons in this body is said to be negatively charged. Understand? Negatively charged. So this body now is said to be charged. Before it was a neutral body. Now due to the presence of excess number of electrons, it is said to be charged. Okay. So similarly, if I have another body, all right, and again this is initially a neutral body. Now if I take out electrons from this body, if I take out electrons, let's say I take out these electrons. How many electrons? Let's say 5 electrons I've taken out from this body. And because I've taken out 5 electrons from this body, now this body will acquire 5 positive charge, because basically positive charge means less deficiency of electron. So here you see that there are less number of electrons present in this body. Okay, so for example, let's say initially in the neutral body there are 100 electrons, but since you have taken out 5 electrons, what will be the number of electrons present in the body now? Now only 95 electrons. But how many positive charge are there? There will be more positive charge than the negative charge. Yes or no? So in this case, there is deficiency of electrons in the body. So because of that, this body now will gain positive charge. It is said to be positively charged. Is it clear? So whenever we talk about charge, it is basically the excess or the deficiency of electrons present in the body. If there is excess of electrons, that body is said to be negatively charged. If there is less number of electrons or deficiency of electrons, that body is said to be positively charged. Okay. All right. So let us look at the types of charges, and we know very well that in nature there are 2 types of charges, the positive charge and the negative charge. So what is a positive charge? It is the deficiency of electrons as compared to protons. So that means in the body, if there are less number of electrons, then that body is said to be positively charged. Whereas if the body has excess number of electrons, that body is said to be negatively charged. Okay. The SI unit of charge is coulomb, as we all know. And what is the value of 1 coulomb? It is equal to 1 ampere second. The dimension of charge is 80 inside of the square bracket. Okay, so let us look at the properties of charges, right? So number one, charge is a scalar quantity. I believe you know the meaning of scalar. Scalar means a quantity that has only magnitude and no direction. Okay, if we say that a body has a charge of 50 coulomb, we don't say 50 coulomb east or 50 coulomb north, right? It has no direction. So charge is a scalar quantity. Charge is transferable from one body to another body. That means you can give charge from one body to another body, as will be seen later on. Charge is quantized. Now, what is the meaning of this? Quantized. Now, this is a very important concept when it comes to charge, or a very important property. This means that the total charge in a body is always equal to the integral multiple of the charge of one electron. Remember, I told you that when we talk about charge, we talk about the electron, right? We remember the electron, we think of the electron. So therefore, the total charge of a body Q is always an integral multiple of the charge of one electron. What is E out here? E out here is the charge of one electron, okay? And N here is a positive or negative integer. I believe you know what are integers. Integers are whole numbers with either a plus sign or a minus sign. Yes or no? Those are integers, okay, including 0. All right, so here n here is a positive or a negative integer. Okay, now for example, let us do one small exercise. Can a body possess 25 into 10 to the power minus 20 coulomb of charge? All right, so let us do this exercise out here. Okay, so here when we say that a body has this amount of charge, so that means this is the total charge of the body, so that is 25 10 to the power minus 20 coulomb. Okay, so let us use this formula, Q is equal to NE. Now to know this answer, all we need to find is the value of N, this N. What is the value of N? Now we say that N here is an integer, is it not? An integer is what? Is a whole number with plus or minus sign. So basically all we need to check is whether N is a whole number or not. All right, so let us find the value of N. So N here will be Q by E. Okay, so Q here is 25 into 10 to the power minus 20 coulomb. And E is the charge of the electron. We know very well charge of electron is 1.6 10 to the power minus 19 coulomb. So coulomb and coulomb will cancel. So if I do this calculation, how much will I get? 25 divided by 1.6, that comes out to be 15.625. Now into 10 to the power minus 20 and 10 to the power minus 19, I will get here 10 to the power minus 1 into 10 to the power minus 1. Okay, so this comes out to be 1.5625. Is this a whole number? Not a whole number. Not a whole number. So can the body possess this amount of charge? No, it cannot possess that amount of charge. Is that clear? So this concept comes from where? It comes from the quantization of charge. Okay, all right. Number 4, charge is conserved. Now what does it mean? Charge is conserved. Have we heard of energy is conserved? Yes, energy cannot be created or destroyed. Yes or no? So similarly here, the charge is conserved means that charge cannot be created or destroyed. Okay, now in the suppose a body like let's say I have in this body, okay, let's say I have in any chemical process, okay, any chemical process or any physical process, if you count the total charge, the total negative charge in the system is equal to the total positive charge of the system. All right, so that is basically the meaning of charge cannot be created or destroyed, or charge is conserved. Number 5, additive property. Now what does this mean, additive property? If a system contains n number of charges, let's say q1, q2, q3 till qn, then the total charge is just the algebraic sum. Okay, the algebraic sum of all the charges. Now what do we mean by algebraic sum? Algebraic sum means we add all those charges, taking into account the positive or negative sign, the plus or minus sign. Okay, for example, let's say a body is given 5 electrons and 2 protons. Okay, you have a neutral body, and to that neutral body, what are you doing? You are giving 5 electrons and 2 protons. Electrons are negative charge, protons are positive charge. What is the total charge in the body? So the total charge in the body Q is 5 of minus E. What is minus E? Minus E here is the charge of the electrons. So how many electrons you're giving? 5 electrons. Plus 2 plus E. Plus E here is the charge of the proton. The electron and the proton has the same charge, same amount of charge, 1.6 10 to the power minus 19. Only thing is the electron is minus and the proton is plus. So if we do this algebraic sum, we end up with minus 3E. Okay, so this is basically an example of the additive property of charge. All right, so another example. Let's say charges of magnitudes 2.5 coulomb, then minus 3.2 coulomb, plus 0.8 coulomb, and minus 4.3 coulomb are given to a body. What is the total charge of the body? Okay, so total charge will be what is just the additive property. Now I can do this, I can just add them directly, because I can see that all the units are the same. All right, so this will be 2.5 minus 3.2 plus 0.8 minus 4.3, and the unit will be in coulomb. All right, so this comes out to be how much? So let me just try this out. 2.5 minus 3.2 plus 0.8 and minus 4.3. This comes out to be minus 4.2 coulomb. Okay, so this is the concept that is going to be applicable in the in the later topic in this same chapter, in Gauss law. Okay, so always remember that you can just add up all the charges. All right, so suppose if this is microcoulomb, let's say this is microcoulomb, then in that case you have to multiply here 10 to the power minus 6, because that is a microcoulomb. Is that clear? Okay. All right. Now what are conductors and insulators? Now this is not something new to you. Conductors and insulators. Conductors, basically they are materials containing free electrons. Okay, so the electrons from the atoms of that material has come out. They are free to come out from the atoms and become free electrons. Now current can pass through the conductors. I think we know very well, isn't it? Like what? Like metals. Okay, like electrolyte, etc. Insulators, on the other hand, are materials that does not contain free electrons. Because of that, current cannot pass through them. Like what? Like rubber, plastic, etc. Okay, now the main difference between the two is this. Let's say we have this body, and this body is a metal, let's say. Okay, and because it is a metal, it is a conductor. All right, so what will happen if we give charge to this body? Let's say if by some process we are able to give charge to this body. So let's say we are giving positive charge to this body. Okay, so we give positive charge to this body. All right, so the positive charge, as soon as they touch the conductor, what will happen? You know, these positive charge will go and distribute themselves, uniformly in the surface of the conductor. It's like they are in motion, they are able to move. Okay, on the surface. It doesn't go inside, but on the surface. So these positive charges, the same for negative charge also. As soon as you give charge to a conductor, the charges will go and distribute themselves. Okay, you're putting the charge only in one spot, only in one space. It's not that you are sprinkling the charges uniformly on the surface. No, you're putting only in one point. But then as soon as the charge hits the surface of this conductor, by themselves they move and they go and sit so that they will be in equal distance from one another on the surface of the conductor. Is that clear? What about if this is an insulator? For an insulator, let's say you give positive charge to an insulator, all right? So those positive charge will just sit right there. Wherever they fall, they will just sit in that spot. They are not going to distribute themselves. They are not going to move and rearrange themselves so that they become like this, okay? So if you put here, they will come here. If you put here, they will stay there. Understand? If you put here, then they will stay there. They are not going to move. Is it clear? So this is the main difference between the conductor and the insulators. Okay, now we have talked about charge. We have talked about a body can be charged. Okay, now how do we charge a body? How do we charge a body? In other words, how do we transfer charge to a body? Transfer charge, or maybe take out charge to a body. Or in other words, how do we make a body negative charge, or how do we make a body positive charge? Now there are various processes by which you can charge a body. Okay, so let us discuss those processes one by one. So the methods of charging. Number one, by rubbing. So basically, if you rub two bodies, there will be friction. Yes, so friction causes the transference of charge from one body to another body. When we rub one body onto another body, electrons are transferred from one body to another. For example, when a glass rod is rubbed with a silk cloth, the electrons gets transferred from the glass rod to the silk cloth. As a result, the silk cloth acquires negative charge, whereas the glass rod acquires positive charge. Let's say this is let's say we have a glass rod out here. Let's say we have a glass rod. Okay, and we have a silk cloth. Okay, what is this? Silk cloth, and this is a glass rod. Alright, so what you do is you take the silk cloth and you rub it. You just rub it around this glass rod randomly. Alright, so due to rubbing, there will be friction, and friction causes the electrons from the glass rod. So these electrons from the glass rod to detach and get deposited onto the silk cloth. Understand? So now the silk cloth will gain one electron. So gaining one electron, and this glass rod is losing one electron. So for that reason, it will gain one positive charge. Understand? So another electron goes from the glass rod to the silk cloth. So now this glass rod will gain positive charge. You got the idea here. So you see here that if three electrons are transferred from the glass rod to the silk cloth, then there will be three positive charge present in the glass rod. Alright, so in this case, if you look now in this system, if you count the number of charge, the number of charge will be the same. Yes, there will be no loss or gain of electrons. Got it? Why? Because if this electron goes back there, it will neutralize. If this goes back there, if this goes back there, it will neutralize, rendering these two bodies to be neutral as initially. So we can see here that due to rubbing, you rub the silk cloth onto the glass rod. Then due to friction, what happens? The electrons get transferred from the glass rod to the silk cloth. Now this is important to remember. Electrons goes from where? From the glass rod to the silk cloth, not the other way around. Okay. So in this case, a few important points, because the silk cloth now has gained electrons. No, and we know that electrons has finite amount of charge, finite amount of mass. So it means that now the mass of the silk cloth has increased. Okay, so silk cloth gains mass. Got the idea? What about the glass rod? Glass rod, not drop, sorry, we are not talking about a person. Glass rod gains mass, loses mass. Let's not say loses mass because that doesn't sound right. Let's not say glass rod gains mass. So let's say like this. Let's say mass of silk cloth increase, okay, and mass of glass rod decrease. Understand? All right. Another example, when a plastic rod is rubbed with a woolen cloth, the electrons are transferred from the woolen cloth to the plastic rod. So which one is gaining electrons? It is the plastic rod that gains electron. As a result, the plastic rod becomes negatively charged, whereas the woolen cloth gains positive charge. Okay, so again, let's say you have this, let's say now this is a plastic rod, and the woolen cloth. Now when you rub this woolen cloth onto the plastic rod, what happens? The electrons from the woolen cloth will go onto the plastic rod. So now the electrons are gained by the plastic rod. So the plastic rod becomes negatively charged. And because the electron has gone this way, now the woolen cloth, there will be deficiency of electron. And the deficiency of electron is denoted by a positive charge. Okay, so which gains negatively charged? The plastic rod. And the woolen cloth gains positive charge. Is this clear? So that is the first method of charging a body. Now second method is by induction. Now what do you mean by induction? Okay, induction is a process where you can charge a body without touching the body. All right, without touching the body. Remember that. Okay, induction. So let's say I already have a charged body. This body is already charged body. Let's say this is a positively charged body. So therefore it will have a positive charge on its surface. Okay, now what will happen if I bring this body onto a neutral body? All right, so let's say this is a metal. Okay, there's a metal. Now this metal initially is neutral. Now once I bring the positive charge near the body, so what will happen? This body now will acquire negative charge on the surface that is near to this body. This is called the charging body. Okay, and it will acquire, let's count 1 2 3 4 5. It will acquire 1 2 3 4 5 opposite charge on the farther end of the body. You see, so initially this body was neutral, isn't it? Just by bringing this charged body nearby, you get opposite charge to this. Okay, opposite to charge charge appearing just like that by itself automatically. This opposite charge appears in the nearer end. That means the nearer face, this face that is nearer to this body. And on the far face, there will be a positive charge. But if you count the number of positive and negative charge here, it is the same. So that the body will be, the total charge of the body will be 0. Okay, now what will happen if, let's say I conduct this, I take a wire and I join this to the ground. Okay, I join this to the earth. This process, by the way, is called earthing. That's earthing. All right, so what will happen to all these positive charges? They will flow onto the earth. Okay, so that there will be no more positive charge here. Let me make this eraser a little bit small. I think that much is okay. So there will be no more positive charge out here. You see, no more positive charge, right? So if you disconnect this wire, what will happen to the negative charge? Now they will go and redistribute themselves on the surface. So I'll have this 3, 4, 5 like that. Understand? So this is how you make a body negatively charged. Okay. Similarly, how do you make a body positively charged? So you bring a negatively charged body. Okay. You bring this body onto a neutral body. So what kind of charge will appear here? Positive charge will appear here. Okay, and 1, 2, 3, 4, 5, 6. Negative charge will appear on the far end. Got it? So the same thing you do, you take a wire and you connect this to the ground. Then what will happen to these negative charge? They will all flow into the ground, and therefore there will be no more negative charge here. And if you disconnect this, what will happen to the positive charges that were there? They will now redistribute themselves. Okay, so they will come like this: 3, 4, 5, 6. So that's how you make a body positive charge. So this process in which you are charging a body by bringing an already charged body near it, not touching, you're just bringing it near. Okay, this is called induction. Now one thing, suppose I bring this body, this charged body. Okay, this is already a positive charged body. Now if you bring this charged body here, we know that there will be negative charge on this face and positive charge on that face. Now what will happen if you take it away? If you take this body away, then these charges, if you remove, okay, then these charges also automatically, they will disappear. Just like that, they will disappear. Understood or not? Why will they disappear? Because there are same number of negative and same number of positive, so they neutralize each other. Is it clear? So that is the process of induction. Okay, and lastly, we can charge a body by conduction. Conduction, on the other hand, it involves touching of the body. Okay, so let's say I have this neutral body, and if I take the rod, okay, I take the rod and I touch onto this body. Let's say the rod is already positive charge. Okay, so what will happen? These charge, they will flow on the body. So now the charges will go and sit on the surface of the body. You see? So what is the main difference between conduction and induction? Induction, you don't touch, there is no contact. Conduction, there is contact. Is that clear? All right, so those are the things that you need to learn when it comes to electric charge. Thank you.